Okay, so let's go back to some things that we've looked at in the past. Let's say we have a right triangle here, and say this is angle theta, and let's label it A over here, and B over here, and C over here. Then we could say the cosine of theta is equal to B over C, right? But if we think about this angle right here, that angle has to be pi over 2 minus theta, right? Because those are co-angles, or not co-angles, complementary angles, okay? So complementary angles have to add up to 90 degrees or pi over 2. So you could say the sine of pi over 2 minus theta is equal to B over C, because that would be the opposite over the hypotenuse, right? Okay. So these two are equal to each other. Okay, we know that from the cofunctions that we did in the past. So now I can rewrite this. It says finding sine inverse of cosine x. Well, I could write that then as sine inverse of, and I can make this sine of pi over 2 minus x. Okay? So that would be true because this cosine of x is equal to the sine of pi over 2 minus x. Then I could think about this and just say, oh, that's going to be pi over 2 minus x, as far as the restriction goes. Okay, so let's see. Did I want to do more than this? No, I'll just put with restrictions, considering the restrictions. Okay. And then cosine inverse of sine x. Well, you could do the same thing there. You could say cosine inverse of, and replace sine x from cosine pi over 2 minus x. And then that's going to get you pi over 2 minus x. Okay? And again, we have to consider where the restrictions are. Okay? And I think that's it for that one. Let me explain a little more on the restrictions. Okay, so I'll just explain the restrictions. Let me scroll up. Okay, so for this first one, the cosine, x has to be between 0 and pi, because you were doing a cosine function for that one. Otherwise, this wouldn't be in the restriction for the original, okay? And then the other one, x is going to have to be between, you wanted a sine of x, so it's got to be between pi over 2 and negative pi over 2. Okay?